Good morning, children. So let's move on to the next theorem from similar triangles. Okay? So till now, what we have seen: basic proportionality theorem, converse of basic proportionality theorem. Then we have seen the criterion for similarity, like side, 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 angle, 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 and then side angle, side criterion, right? So now we are moving on to the next one. Already in between, in one of the examples or exercise problems, we got another relationship with the similarity of triangles when perimeters are given, is it not? So when ratio of sides, whatever you are taking, so there you have like it's a constant. If you say, then ratio of their perimeters also yields the same constant, right? So this is what we have already seen, and now we are moving on to areas. So perimeters is done, right? Now we are going to discuss about areas. So ratio of areas of two similar triangles is equal to the ratio of squares of their corresponding sides. So don't get confused with the area and perimeter, where perimeter here is sum of the sides, is it not? So when S1 by D1 is equal to something K, you can write S1 is equal to K times of D1, is it not? So therefore S1 plus S2 plus S3 can be written as K times of D1 plus D2 plus D3. So what is happening? The ratio of perimeters, whatever is there, is of course equal to the ratio of the sides. But what is here? Ratio of areas is equal to ratio of squares of their corresponding sides. Ratio of squares of the corresponding sides. So now let us suppose that ABC is similar to PQR. Okay. Now we are bothered about, we should know area. What is the formula for area? Half base into height. So we need to know height. That means altitude. So drop a perpendicular from A to M. So this makes an angle of 90 degrees. Therefore AM is the height now. BC is the base. Similarly, drop PN, which is a perpendicular to QR. Now base is QR and the height is PN. Now area of ABC by area of PQR will be half base into BC into height AM. Here also half base QR into PN. So that is what we are now going to say, that area of triangle ABC must be equal to squares of their corresponding sides. Is that what we need to prove? To prove that, we have already considered the heights, and then now triangle of ABC, area of triangle ABC by area of triangle PQR is half base BC into height AM divided by half base QR into PN being the height. So half will get cancelled. Now we are left with BC by QR into AM by PN. For convenience, I am reading it like this. See, here it is written as BC into AM by QR into PN. But see, BC by QR, that is base by base, into height by height. This is what I can see from here. Yes, now see, if these two triangles are similar, now it is obviously understood that angle B is equal to angle Q. Is it not? And now this is 90 degrees. This is also 90 degrees. Two angles are same. So from angle criterion, you can say that BMA, triangle BMA is similar to triangle QNP. So what happens here? What happens when these are similar? Then AM by PN is equal to AB by PQ, is it not? And similarly, AM by BM is also equal to PN by QN. Yes, right, absolutely right. But what is BM? Half of what is BM? It's a part of BC, right? So now let us see what we are going to see. So these two are similar triangles. So therefore AM by PN is equal to, right? AM by PN is equal to AB by PQ, AB by PQ. But again, from these two similar triangles, you have triangle ABC is similar to PQR, that we know. So AB by PQ is equal to whatever the AB by PQ you got now, right? This is equal to ratio of heights, is it not? But AB by PQ is equal to ratio of bases also, right? AB by PQ is equal to ratio of bases, also ratio of the other corresponding sides. So we are writing the same, AC by PR. So from this part, AB by PQ is equal to BC by QR. Now we are going to substitute in place of BC by QR, AB by PQ. But what is AB by PQ, dear? From second equation, AB by PQ is equal to AM by PN. So in place of BC by QR, you are going to get AM by Pn, right? So that is am square by Pn square. That comes around am square by Pn square. Or the other way around, what we have to prove is base square by base square. So we got it in height square by height square. Or you can say base square by base square. How do you get? BC by QR is AB by PQ. So substituting that one, AM by PN is equal to AB by PQ. So in place of AM by PN, you will get BC by QR. So substituting that, you are going to get AB by PQ into AB by PQ is AB by PQ whole square. That is, what is AB by PQ here? AB is this side by PQ being this side. So corresponding sides square. Similarly, from the third equation, when you say AB by PQ whole square, then that is equal to BC by QR whole square. That is equal to AC by PR whole square. Is it not? So therefore, hence proved. So area of triangle ABC by area of triangle PQR is AB by PQ whole square, which is equal to BC by QR whole square, which is equal to AC by PR whole square. Very simple. The only thing what you have to see here is that once when these two are given to be similar, you have to take any half part of the triangles and then say that those are similar. Automatically you will get the ratios of heights in terms of the ratios of corresponding sides. Thus, when ratios of the corresponding sides square is determined, so then the square of the corresponding sides is equal to the square of other corresponding sides is equal to square of the third corresponding sides. Thus, we will be getting, till now so we were getting AB by PQ is equal to BC by QR is equal to AC by PR. Once when you take the square of one particular thing, ratio, then square of another ratio and square of another ratio, all three will be equal. So this is what you are going to do it here. This is a direct textbook theorem. No extra steps are needed. Only thing is that you have to show that both are similar and then substitute the height values here. Okay, children. So this is from your textbook only, theorem 8.6. Go through that, and if you have any doubts, you can ask me. Let's see the examples here. Prove that if area of two similar triangles are equal, then they are congruent. Area of two similar triangles. Let me say that it is, one is ABC, the other one is PQR. So what is that? Area of this is equal to area of this. What is the, when you say that area of this by area of this, if I take area of this by area of this according to theorem 8.6, it is AC square by PR square, which is equal to AB square by PQ square, which is equal to BC square by QR square, is it not? So now, but what is given? Areas are equal. That means this area by this area, this step will become equal to 1. Thus, this is equal to 1. Hence, the ratio of the squares is equal to 1, which implies AB square is equal to PQ square, BC square is equal to QR square, AC square is equal to PR square. Taking root on all the sides, on both sides, you will get AB is equal to PQ, BC is equal to QR, AC is equal to PR. That means corresponding sides are equal. Corresponding sides are equal. When we say that the corresponding sides are equal, already due to similarity, you have corresponding angles to be equal. Now corresponding sides are also equal. Why? Because areas are equal. Thus you can say that these two triangles are congruent, and this is a symbol for congruence. Okay children, so this is how you have to prove. This is another example. Like maybe sometimes some sides ratio values will be given. You have to find out the unknown side. Very simple. Triangle ABC is similar to triangle DEF. Let us draw. A, B, C, and the other one is D, E, F. These two triangles are similar. Right now, what are all given then? And their areas are 64 and 121 centimeters respectively. This is of 64 centimeters square and this is of 121 centimeters square. Now you know area of this by area of this is equal to AC square by DF square. Okay. Similarly, BC square by FE square. Similarly, AB square by DE square. So what is given here? Areas are given to us and EF value is given to us. EF is given to us. So what is the side corresponding to EF? It is BC. It is BC. So find BC. So what do you say? 64 by 121 is equal to EF square by BC square. What is EF square? 15.4 whole square by this one. So then substitute in the ratio, find, simplify this, and you are going to get this as 8. So what is the use of this theorem? Once when you know area and any one side, you can find out the other corresponding side of the other triangle. Okay children, very easy exercise this one. You don't need much to prove. You will be only given, you have to use only one formula, that is area of the triangle 1 by area of triangle 2 is equal to square of the corresponding sides. That is what which is very important here to keep in mind. Okay, so let's see in the next class.